Welcome to Interpreting Probability Distributions. This video will be fairly similar to the video on probability distributions. We'll just be practicing with another example. So in this example, consider the below probability distribution for the winnings from a slot machine. So the winnings are in dollars. You can have -$1, as in you pay to play and you get nothing out, so you lose $1. $0, $1, $5, and $100. These are your net winnings. So you pay $1 to play, and if you get the dollar back, you have $0 in total winnings. First up, what is the probability of losing money? So we were looking at losing money. There was only one way that we lose money with this slot machine, which is if we come out with -$1. And then we want to know the probability. So the probability corresponding to that would be our 0.7. So the probability of losing money would be 0.7. Next up, what is the probability of winning money? So winning money just means we come out with a positive amount of money. So there are multiple ways that could happen. We could come out with $1, $5, or $100. They're all ways to win money, which means that we have 3 pieces of our probability, which can be added together. So for winning money, we want to include all of the possible ways. So we have our 0.1 probability for winning $1, our 0.01 probability for winning $5, and our 0.005 probability for winning $100, which gives us 0.115 as our probability. Next up, we want to know what is the most likely outcome. So for the most likely, that means the one that has the highest probability. Remember, the closer the probability is to 1, the more likely the event is to occur. So we are looking for the largest probability. Or the largest probability is outcome, the outcome that corresponds to the largest probability. So in this case, we have lots of very small probabilities, and that 0.7 is our largest. So the largest probability is the 0.7, which then corresponds to a winning of -$1, or in other words, a loss of $1. So the most likely outcome is to lose $1. And then last up, we want to know what is the probability of not winning $100. So there are 2 ways we can do this. One option is to just list all of the ways we can not win $100 and add them up. The other way we can do this is to think about it in all, the probabilities should add up to 1. And so if the probability of winning $100 is 0.005, then the probability of everything else should be anything left over. So it should be whatever is left over to get up to 1. So winning $100 is 0.005, or in terms of percent, 0.5%. So if there's a 0.5% chance you win $100, then the remaining percent is the chance we don't win $100. So adding in our not should be, in terms of percent, 100% minus 0.5%, or 99.5%. In terms of probability, we could do 1 minus 0.005, and we get 0.995. So this 1 is sort of the probability of anything happening. So this is basically the total probability. And then this part here, we're taking away the winning $100. So anytime you want to do not, what is the probability of something not happening? You can always do 1 minus the probability that it happens. So again, if we want to find the probability of something not happening, so not $100, not whatever it is, then we can always do probability of not winning $100, whatever it is equal to 1, the overall probability, total probability, minus the probability of getting that. So again, all of these are the same thing. So to find the probability of not whatever, in this case it was not winning $100, we just do 1 minus the probability of whatever that thing was. So minus the probability of winning $100.